Welcome at ICT University. In this video, we'll talk about liquid crystal displays or LCD, which have become the standard for laptop computers and flat panel monitors. It is the successor of the older cathode ray tube or CRT monitors, which were back in the days the only type of display available for desktop computers. Those older monitors were as deep as they were wide across, so they took up far more desk space, and larger monitors would be quite heavy as well. So, by the time LCD started to become more cost-effective, CRT monitors disappeared. In the beginning LCD was much more expensive than CRT monitors, but as the technology became more and more prevalent, the cost began to drop, and I would guess that around 2007, CRTs were gone in most workplaces and most home environments. Not only did the cost of LCD monitors come down, but the technology of LCD continued to improve as some early implementations suffered from distortions of the image based on the viewing angle. What still happens to a degree even today, but far less than what it used to. Today, LCD screens produce very high resolution and very clear images. They're cost-effective, and they take up far less space than the CRT monitors. LCD is a technology that is based on using a liquid crystal material that is effectively sandwiched between two clear plastic sheets with a light source behind everything to provide illumination. The liquid crystal material is then divided into many small squares, each one representing a single pixel of the image. Each square on the display is independent of the others, and each is capable of 32-bit color depth, meaning that a total of 2 to the power of 32 colors can be displayed, which itself is a very high number. Over 16 million, in fact. But it's not just the total number of colors that help to produce higher quality images. It's the use of those colors to produce features such as gradients or transition, shadows, transparencies, and various other lighting effects that also improve the quality. These squares are more commonly referred to as pixels, as I had just mentioned a moment ago, which, by the way, is a contraction of picture element, in case you've ever wondered where that term originated. And the display resolution is generally referenced by how many pixels wide and how many pixels high the display can support. For example, you might see a display resolution listed as 1680 by 1050. This indicates that there are 1680 independent rows of pixels arranged across the screen from left to right, and 1050 rows of pixels arranged from top to bottom. You may also see values such as DPI, which stands for dots per inch, and is a count of how many dots, or in this case pixels, there are in a linear inch. DPI is used more commonly with printed images as opposed to the resolution of your screen. The more applicable term to a display is PPI, which is pixels per inch. In both cases, the more pixels that are used to create an image, the higher the quality you'll get. All LCD screen types still rely on some kind of backlighting for their illumination. There are two primary methods of providing that light, which are cold cathode fluorescent light or CCFL, and light-emitting diodes, or LED. CCFL lighting relies on a standard fluorescent light behind the display, but some models may use more than one to help produce more even distribution. But if there are multiple lights, then each one requires its own inverter, which converts DC power into AC. This can help to produce more even lighting, but the more inverters you have, the more power the unit will draw and the heavier it will be, and it might also produce more heat. By contrast, LEDs do not require inverters. They can run directly from the DC power of the motherboard and are therefore more efficient and environmentally friendly. The greater efficiency also means less energy waste in the form of heat. So, why would anyone use CCFL over LED? As is the case with many technological advances, CCFL was cheaper, but these days the cost of LED has dropped and has pretty much become the standard. Looking at some of the performance measurements for LCD monitors, the response time is a measure of how quickly any given pixel can respond to a change, which is typically measured in milliseconds. Now, how to define a change, particularly since there are over 16 million colors? So, in this context, change is defined by the two extremes of going from completely black to completely white, then back to black. In current models, a respectable response time should be somewhere around 10 milliseconds, although for users such as gamers or maybe graphic designers, values as low as 1 millisecond would be desired. The lower the response time, the higher the cost. Lastly, LCD is not a single type of technology. There are several different iterations, each with its pros and cons. First off, we have in-plane switching or IPS, super place-to-line switching or PLS, vertical alignment or VA panel technology, and twisted pneumatic or TN panel technology, and transistor translator logic or TTL. We will quickly be going through each one of these. In plane switching is considered to have the best color accuracy and viewing angles and overall image quality of most LCD displays. But the subsequent technologies would usually offer some enhancements to specific performance considerations. For example, super plane-to-line switching was originally developed by Samsung, and it is very similar to IPS, but it tends to be a little bit brighter, and also claims to increase the viewing angle to reduce the amount of image distortion as you increase the angle. But it could require more power due to the increased brightness. Then, vertical alignment is somewhere in between the twisted pneumatic and the IPS. It does offer wider viewing angles and better quality, but it had slower response times. Twisted pneumatic then does offer faster response time, making them the preferred choice for gamers, but they didn't have quite the range in terms of viewing angles and contrast ratios, and they also draw more power. And then TTL. TTL is more of a protocol or a processing method that describes a monitor that accepts digital signals only as opposed to digital and/or analog, such as an RGB or red-green-blue display, also known as component video. And in most cases, it also used lower voltages, so TTL processing is not very common in today's more demanding displays. In most of today's business environments, it's likely that just about any LCD monitor would be more than sufficient for standard office activities. It's really not until you get into the very specific applications of gaming, animation, 3D rendering or graphic design, that you'd start to see the higher-end models. So, in most cases, for most people, it usually just comes down to finding a satisfactory model for the right price. That was it for this video. Thank you for watching and don't forget to subscribe for more content.